Good afternoon. My name is Peng. I'm a professor in mechanical engineering. I'm also the director of the mysterious Mobility Transformation Center. We are actually opening the M-City for a possible tour, and I understand that the tour will start at about 1:30. So if you would like to have a chance to actually see M-City, please follow the instruction and go to take the shuttle that will bring you to see M-City. So what I'm going to do in the next 10 minutes also is to tell you a little bit of what are we doing in the Mobility Transformation Center. And this is going beyond robotics. It's a very wide range of participation from faculty members from many colleges and schools within the University of Michigan. And I'm going to give you a very brief introduction of what we do. Next slide, please. Or maybe I can advance the slide. Okay. All right, so if you go to any newspaper or any trade show, it is very hard to go to open the newspaper any day without seeing a headline that's related to connected and automated vehicles. So what are the promise is that over the last decades, a couple of decades, sensing, computation, control, artificial intelligence, and computation power and storage, Internet of Things are making it possible for us to really envision a practical implementation of many of the technologies that will make vehicles connected and smart. So if you imagine what is the potential of smart vehicles or connected vehicles, just look at what happened when you connect personal computers together through internet. And that's, I think the analogy is quite similar over there. So M-City. So M-City was designed about 2.5 years ago, and we actually started construction, and we had a grand opening last July. And on the opening day, we did feature a demonstration from about 13 companies. Today, MTC already attracted industrial members. 17 of them are our leadership circle companies. Each one of them pledged to support us at the level of $1 million every 3 years. And we also have 43 affiliate members. They are also very important. They provide cash, also knowledge, software, hardware devices to support our research. So this is M-City. If you want to see close by, you will, again, 1:30, we have a tour bus. We will bring you to see M-City. Unfortunately, because of safety concerns, we decided not to give any dynamic demo. So what I can tell you is that M-City is heavily booked. So it is either under construction, so we are still trying to add communication, control, sensing systems to M-City. Other than those, the test track is heavily booked by many of our industrial members to use for testing. In addition to M-City, MTC, so sometimes people jokingly ask me why your acronym is MTC and MCT. I say, no, it's M-City, not MCT. But what does MTC do? In addition to M-City, we also are constructing 3 living laboratories. So in the last 2 years, we had been giving this update to this event. Just as a quick summary, our vision of building the city of Ann Arbor to be a connected Ann Arbor living laboratory has not changed. In this living laboratory, nothing will be controlled, but we will be collecting a lot of trip information and driving information so that we can build many other future technologies, including deploying autonomous vehicles in the city of Ann Arbor. So it's not going to happen this year, but I can guarantee you that we're working hard to make that happen in about 2 to 3 years. So within about 2 years, all the major intersections of Ann Arbor will be connected and about 10% of the vehicle population will be connected. Similarly, we work very closely with the Michigan Department of Transportation to implement connected vehicle technologies in the southeastern Michigan highway network, and the highlighted network including 94, 96, 275, and 23. And the vision is that about 140 miles of highway will be connected, and we are working very closely with our 60 industrial members to recruit about 20,000 corporate fleet vehicles to have the connected vehicle capabilities in the southeastern Michigan. And finally, in about 2 to 3 years, you probably will start to see level 4 autonomous vehicles on the streets of Ann Arbor. So you have all seen this video clip featured by Ford Motor Company. So Ford is the first company that has demonstrated autonomous driving in snow conditions. And this is a test done inside M City. So for the interest of time, I'm not going to play this video again. In addition, if you ask what other robotics-related work we are doing in MTC, so first of all, we are supporting about 22 research projects that's basically supporting about 15 PhD students and involving many other students. This is just one example of robotics-related activities. So what you are seeing here are robotic pedestrians, mannequins, that they are used to test vehicle-to-pedestrian safety functions. So these safety functions must use either camera, radar, or maybe LiDAR to detect the presence, the location, and predict the speed and motion of pedestrians. And many of these mannequins, as you can see, are hanged from a overhead crane system. It's probably not very clear for you to see, but this is obviously a crane system. Actually, there is an overhead crane system here. And again, it's not easy to see the one on the lower right corner, but if you see the shadow, if we actually have working Wi-Fi, because I understand 500 people are connected to the Wi-Fi system, so we can't really play this video. But if you play this video, you will see that there is a frame that's moving, the shadow is moving. So this is also connected from the top. Oh, actually, thank you. We got internet. If you see the shadow, it looks like this pedestrian is jumping, and the motion wasn't very natural. So I'll show you one system that was designed by the College of Engineering students at University of Michigan. This is actually a class we call ME 450. It is a capstone design class, and I work with 2 teams. So the first iteration wasn't robust enough, and I worked with a second team to perfect the design. Yes, we can play the video. As you can see, this properly dressed mannequin with amazing blue color is walking fast enough like a human pedestrian. So what we could do in the future, again, you can see that there's no overhang gantry system. We can move the robot to anywhere. It walk as fast as about 5 meters per second. So not quite at the maximum speed the Department of Transportation want to see, but it's awfully close to what a human is able to do. And in this class, students learn mechanical design, sensor, actuator, and actually put together the whole system, including a triggering system. So when a car passes through a ultrasonic beam, the robot will start walking. And instead of risking the lives of our undergraduate students, this is the mechanized pedestrian we plan to use in our pedestrian safety systems. So in addition to robotics, in addition to engineering, there are many other things that must be solved before we can implement connected and automated vehicles. We all know that robust perception and operation are very difficult challenges, sunlight, snow, and others. Costs must come down. Also, user acceptance. So we actually have seen some survey done by other research institutes that some people have reservation about riding in autonomous vehicles. They would rather eat meat made in factories before they ride on automated vehicles. So I think improving the technology and improving user acceptance are definitely important things that we need to keep in mind. Human-machine interface and external human-machine interface are important problems too. So some of you probably heard that a company called Alpha Google was testing their vehicles in California. So they are not yet brave enough to test their vehicle in Michigan. That's okay. But their vehicles have driven about 1.4 million miles, and they have been hit by other vehicles 14 times, and they hit a bus once. So why are their vehicles hit by other vehicles so often? And so if you look at statistics, it takes about 500,000 miles before you see a police-reported crash. And on average, Google vehicles have an accident about less than 100,000 miles. So why? Because their vehicle doesn't drive normally, doesn't behave like a human-driven vehicle. And that's why their vehicle was not driven harmoniously with other vehicles, and we call that external HMI. So in the future, we hope to have knowledge and guidelines in terms of how an autonomous vehicle should behave so that you don't behave eerily and have conflicts with other road users. There are many other issues, legal regulation issues, standards, and verification. So we are working on those problems as well. And finally, insurance. So what's the insurance policy, who's paying for what? Also, we also know that autonomous vehicle has unknown societal impact, and we certainly want to be the institution where we study engineering and beyond engineering problems. Most important thing to remember is that there are a lot of potentials. So if we don't do things right, we can do more harm than good. And it's important that a traditionally strong automotive and robotics school like University of Michigan take the lead in solving all of these problems. For connected vehicles, we also worry, can we afford it? So we know that we have a lot of potholes to fill, a lot of bridges to fix. And this year, MDOT announced that they will be investing at least $1 billion this year fixing the roads. But in the meantime, they have also invested connected infrastructure at 17 points in the streets of Michigan. Even though the budget is a very small fraction of the $1 billion, but that shows you that they have a very nice balance between short-term problems and long-term needs. Bandwidth assurance. So when vehicles are all connected and pedestrians are connected, just like the Wi-Fi problem we have in this cafeteria, whether the bandwidth can be assured in a very busy city is a problem that we need to think about and find a solution to. Cybersecurity, everybody's worrying about cybersecurity, privacy. Our governments watching us, are our secrets safe? These are all very important problems we need to solve. And also big data. We all know that there are a lot of potentials for big data, but how to do it, who will do it, and why do we do it, and who will pay for them? So these are all important problems, but again, there are a lot of potentials. So I want to show you a final eye test that we are supporting many research projects. I know you cannot read often, so I created a word cloud, and this gives you some ideas, the kind of research that we are doing. Yes, we are doing automated vehicles, autonomous vehicles, connected vehicles, but there are many other things we are working on. Finally, I want to conclude my talk by acknowledging our industrial sponsors. Without their support, MTC will not be able to do anything good. So these are our 17 leadership circle companies. Again, we are meeting with them regularly on average every 2 months we have a general meeting, but we are meeting with them in working groups about 6 times a month. That's the level of workload we are talking about. It's a huge commitment, not only financially, but they are really taking intellectual leadership in working with University of Michigan to create this one-of-a-kind industrial alliance that we are making things good for the state of Michigan. Thank you. So if you have interest, please join us for the tour for M City. Thank you.